Okay, we've already learned how to multiply and divide complex numbers when they're in rectangular form. So it's done slightly differently now when we're doing multiplication and division of complex numbers when we're in polar form. Okay, so these are the rules. Now it looks a little bit cumbersome here looking at all the different variables being used. But anyway, if Z1 is this complex number, okay, R1 cos theta 1 plus I sin theta 1, and Z2 is this complex number in polar form, so R2, a bracket, cos theta 2 plus I sin theta 2. If I want to multiply the two together, Z1 by Z2, what you do is you multiply the two R's, okay, they're moduli I should say. You multiply R1 by R2, and then you add the angles. So it will be the cos of this angle, so theta 1 plus theta 2, plus I sin, you add the angles again, theta 1 plus theta 2. Okay, and then you just tidy it up. So that's multiplying complex numbers when they're given to you in polar form. For division, if Z1 is equal to this complex number in polar form and Z2 is equal to that complex number in polar form, and we want to divide Z1 divided by Z2, you divide the two moduli, so it's R1 divided by R2, a bracket, and then you subtract the angles. The cos of theta 1 take away theta 2 plus I sin theta 1 take away theta 2. Okay, so that's the rule for division. So when it's multiplication, you multiply the two R's and you add the angles. And for division, you divide the two R's and you subtract the angles. So that's the rules there. So let's look at the first example. Z1 is 3 times the cos of pi over 6 plus I sin pi over 6. And Z2 is 4 times the cos of pi over 3 plus I sin pi over 3. Find in the format of x plus yi. So that's rectangular form. So eventually we want to write it in rectangular form. Find Z1 by Z2. Okay, so again, because they've given them to me in polar form, I'm going to use the rule. So Z1 multiplied by Z2, that means I'm going to multiply the two moduli, 3 by 4. Okay, so I get 3 multiplied by 4 times the cos of, you add the angles, so pi over 6 plus pi over 3, okay, plus I sin this angle plus this angle. Tidying it up further, that's going to be 12 times the cos of. Pi over 6 plus pi over 3 works out to be pi over 2. Plus I sin pi over 2. Go to your calculator, type in cos pi over 2, you get it back as 0. Type in sin pi over 2, you get back 1, so that's 1i. Multiply in by your 12, and you're going to get 0 plus 12i. You have now written Z1 multiplied by Z2, you have written it in rectangular form. Okay. Division next. So part 2 said find Z1 divided by Z2. So remember your rules for division. So I'm now dividing complex numbers that are in polar form. So divide the two moduli into each other. So it's going to be 3 divided by 4, 3/4, times the cos of, subtract the angles. So it's going to be pi over 6 take away the pi over 3, plus I sin pi over 6 take away pi over 3. So you end up with 3/4, the cos of minus pi over 6 plus I sin minus pi over 6. Now remember, the cos of a negative angle is the same as the cos of the positive angle, plus I sin the negative angle is the same as minus I sin of the positive angle. Go to your calculator. Okay, the cos of pi over 6 is root 3 over 2, and the cos, or the sine of pi over 6 is going to be a half, and remember there was a minus there as well. And multiply in then by 3/4. So you're going to get 3 root 3 over 8 minus 3/8 of I. So that is Z1 divided by Z2. Okay, written in complex number format. Written in rectangular format, sorry, I should say. Alright. Sorry, now just before I move on to that, if you forget those rules for multiplying and dividing complex numbers when they're in polar form, you can take a much longer route, okay? So like say when you're, say for the multiplication one there, we have Z1 multiplied by Z2, okay? So that was 3 times the cos of pi over 6 plus I sin pi over 6, and then I want to multiply that by 4 times the cos of pi over 3 plus I sin pi over 3. So let's say you forget the rules for multiplying and dividing complex numbers when they're in polar form. And you look at it and say, right, well, can't I just multiply it all out and split the brackets? You can. Look how complicated it's going to become though. So if I multiply 3 into the bracket here, it's going to end up being 3 cos pi over 6 plus plus 3 I sin pi over 6. And then I'd be multiplying that by multiply 4 into that, and you're going to get 4 cos pi over 3 plus 4 sine pi over 3. And then if you want, and you go off and you split the brackets, so it's going to end up being 3 cos pi over 6 multiplied by 4, cos pi over 3, plus 3 cos pi over 6 multiplied by this. So 3 times 4 is just a 12 straight away. Like I could have put 12 there, but anyway. That's 12I cos pi over 6 sine pi over 3. Then it would be plus I times 3 sine pi over 6. So plus I times 3 times sine pi over 6 multiplying by 4, which is 3 4s are 12 again, so that's plus 12I sine pi over 6 cos pi over 3. And lastly, I3 sine pi over 6 multiplied by I4 sine pi over 3. Well, 4 3s are 12. Plus by plus is still a plus, that's plus 12. I by I is I squared. Sine pi over 6 sine pi over 3. Okay, now look at how cumbersome this is starting to look. Now I will get there, right? But it's going to take a lot of work. So again, if I tidy that up, that would be 12 times the cos of pi over 6 cos pi over 3. Now, if you tried typing that into your calculator, like you'd eventually, remember your I squared is minus 1, and you'd eventually group your real numbers with your reals and your imaginaries with your imaginaries. But if you try typing cos pi over 6 sine pi over 3 into your calculator, it'll say error. It won't be able to do it for you. What you'd end up having to do is use your trig identities on page 14 of your log tables, or 15 of the log tables, where you'd end up trying to change products into sums. And you'd have to do it for this one, you'd have to do it for this one, you'd have to do it for this one, and do it for this one. So you'd be trying to change products into sums, so that then you'd be able to use your calculator to turn it back into rectangular form. So by all means, if you want to put that extra work on yourself to do that, go for it. But I would be advising you learn the rules for multiplication and for division of complex numbers when they are in polar form, because that is going to be a hell of a lot of work, and it's going to be very, very time consuming to get out your end answer. You would get out your end answer, definitely, but it's far too much time being consumed. So just stick with those rules, okay? So multiplication means you multiply the two moduli and you add the angles, and division, you divide the two moduli and you subtract the angles. So in your books on page, 307 and page 309 or 10. Yeah, page 307 and page 310. I want you to do, on exercise 12.8, I want you to do question 10, part 3. Question 11, part 4, that's division. Question 12, all of it. Okay, so solutions there to question 10. Okay, so you're multiplying them, so multiply the two moduli and add the angles. Okay, and you were to leave it in polar form. They didn't ask you to write it in rectangular form at all. Question 11, part 4. Again, you could go one step further here, because I can say 3 times the cos of the negative angle plus I sine the negative angle could end up being written as 3 a bracket, the cos of pi over 6 minus I sine pi over 6. Question 12, the first part, you should get out the 6 times the cos of 5 pi over 24 plus I sine 5 pi over 24. Part 2, you should get out 50 times the cos of 3/10 of pi plus I sine 3/10 of pi. Part 3, you should get out 3 times the cos of pi over 16 plus I sine pi over 16. And the last part there, 3 times the cos of pi over 14 plus I sine pi over 14.